everyone. I'm Qing, Technical Support Engineer of Asia and Oceania Center. Today, I'm going to have a presentation about SuperMap Boost Smart Transportation. The presentation will be introduced from the following four aspects. The first one is about how to construct a basic transportation application system, and the next we are going to talk about how to further construct a more complete system of transportation business. We call it Transportation One Map platform. And then, because of this 3D technology development, we will talk about why transportation construction needs 3D technology and what 3D technology can do in transportation construction. At last, with the development of big data, we are going to talk about how to integrate transportation construction with big data technology. Now, firstly, let's look at how to construct basic transportation GIS system platform. First of all, let's have a look at the system architecture of transportation service platform. All the system cannot be constructed without equipment and software. So the second and most important layer is data management, and data is the source of GIS as well. Although there are various data related with transportation, including spatial data and non-spatial data. All this data need to processed, classified, and stored based on a certain data standard. And the next is what kinds of services need to be used for developing applications. It is based on the requirements of the system, such as the basic applications of transportation GIS system, may realize route network management, facilities management, statistic analysis, or route design, navigation, such as this. And we may need this service. We may need these services for these functions, such as map service, data service, and some analysis services, such as network analysis service, spatial query service. And the last layer is the user layer. We need to know which terminals should be used, who will use this system, and all these modules form a complete system, and we will mentor about the data management and how to realize applications through services. Firstly, let's look at how to integrate multi-source of data in a system. We can integrate the spatial geographic data in a map by thematic map. Data for category can be displayed on a map as a layer. Each layer can be controlled through layer management and scale. Besides, facilities information is usually saved in the form of documents. But we can realize visual management of facilities after symbolization and associate the attributes with this visual information of facilities. User can easily query the status and the information of various facilities on the map, and clearly understand the spatial distribution of them. There we all can realize spatial query and attribute query of the spatial elements. The platform supports the input of keywords query and also supports the clicking of querying element details on the map. And system can provide the special function of traffic thematic data. The display it and display the results on the map in the form of thematic chart, such as we can statistic the road length and realize the construction fund statistics and with the types such like columns, diagram, line, or bubble. Network analysis is the basic analysis in GIS, which can realize past design of two locations and lists all routes available. It can be the shortest route or the route cost least time. At the same time, with the mobile application development, route navigation between 2 points can be realized. For the problems found in the process of petrol inspection, professionals can input the detailed information, location level, and other information of the problems through the mobile terminal for reporting. At the same time, the reported issues are stored in a specialized database, which can be displayed and managed in the platform. These issues maintenance status can be checked on the map, such like the red icons represent issues that have been submitted but not fixed. And the yellow icons means the issues are being solved, and the green icons indicates that the problems have been solved and passed the acceptance. Besides, users can check the details of every event. For emergencies, GPS is used to locate the incident. Users can quickly fill in the information. Assisting multimedia means such as photographing, hand drawing, audio, and so on, all clearly display the site status so as to realize real-time report based on mobile network. Then the next, we are going to further learn about how to construct a more complete system of transportation business. Firstly, let's have a look why this system needs to be improved. There are also many other businesses applications need to be integrated in the system, such like the railway business, aviation business, traffic service, post, or logistics, and so on, are all involved in transportation. And each of them has their own business requirements. So how to assist the industry to share and integrate spatial geographic information resources, and how to integrate the various business applications into one system, and how to save the construction costs of industry spatial data management to improve the quality of data service and user experience. All these questions need to be solved. Let's first also say what's the challenge of transportation GIS. Firstly, with more and more GIS data generated, how to manage, store, and update the increasing information. And there is also a large number of repeated and decentralized spatial information, and how to optimize it. In addition, there is a lack of unified standards for the management of space information, and lack of spatial information sharing mechanisms and technical means. So the last change is that with the development of internet electronic map, how to construct a system that more professional, more reliable, also more practical applications. Um, with these questions, here we propose the IKW model to solve deepening industry application. It is a development mode from data to wisdom. In the traditional way, we always solve problems according to the data we have. So we can only do a few applications around the data. But if we further integrate the data, extract the valuable information, we can do much more. And the future development direction is to solve the deeper industry problems in a more intelligent way. With the new development modes, here we propose transportation one map, which can integrate transportation industrial special resource and provide the application foundation of traffic spatial information. Also can be a platform of spatial information sharing within the transportation industries. This case shows how to journalize information spatial splicing based on one map. The first level is City Department of Transport, which provides local transport semantic data, road network, rail network, and the second level is Province Department, which aggregates of provincial traffic semantic data. The third and the last level is national department, which aggregates national traffic semantic data. So the main ideas of transportation one map can be understood that this. The business information integration of each region can be spliced in space to achieve a complete picture. This vertical business integration and horizontal regional splicing spatial information framework is called one map. The steps to realize one map integration from data collection, information integration, service sharing, and to the family realize intelligent management through cloud technology. Based on above ideas, we have developed the open framework product of one map and formulated this standard system. Traditional mode is to develop a specific business for a requirement. This new platform integrates multiple industries into one system through a unified GIS management platform, which is effectively improve resource utilization and sharing. With the next to look at what the platform should build. The content includes standard construction and data construction and the system construction. Let's firstly have a look how to organize standard construction. There are three parts: management specification, data specification, and service specification. As the core construction is data specification. This part mainly discusses how to standardize different types of data. For vector data, raster data, attributes data, or other data, we need to standardize them, and then according to the data management method and the core metadata standard of one man establish the data classification system of one man. Then the data classification system can be divided into information service, graphics, schema, and interface, and their respective specifications are established to generate services sharing specification. Besides, the management specification can be established by creating data document specification and data backup specification so as to achieve one map standard system. And the core content is how to convert data to services. Each industry data has its set of data. We provide classified storage based on the data standard. Each industry data can be divided into general spatial data and industry private spatial data. And the general spatial data can be integrated to one general spatial data and one traffic permit spatial data. So the general spatial data can finally, there are three types of database composed transportation, geographic information data platform, the general spatial data, which store basic geographic data, and the traffic publisher spatial data, which stores traffic semantic data, and all the industry private spatial data. The next step is to organize the construction of transportation service platform after data classification. Firstly, we need to know the user layer, who will use these services, what they want to do with these services, such like the business department. They may want to provide comprehensive functional services, integrate application system, and develop framework SDK. The decision-making department may want to organize spatial presentation of data mining and the spatial statistical analysis of traffic. For the public, they manage detailed and accurate travel services as well as real-time traffic information. Therefore, we first need to publish static data as GIS general service. Which provide the basic functional services. Then dynamic data is published as data service or information publishing service, which providing real-time services. We also need to publish data mining results as professional transportation services, providing statistical services and analysis services. Finally, mutually support is organized through shared service platform. Through data management and service management, one map system is built to organize the application to users and generate standard application services at the same time. Each level is based on its corresponding standards. Finally, the platform will form three types of service applications: map service, data service, and functional service. These applications can be obtained by accessing the platform Each service corresponds its functions to meet the requirements of different users. Here, let's look at a case of one map application. This is one map platform of Jiangsu Province Transportation. The homepage integrates a data sharing module, or service management module, or public information publishing module, and provides application interfaces of resource center, development center, map center and application center. All business applications are integrated into the application center, including road application, railway application, airports, public traffic, and port applications. The second case is traffic emergency command platform of Xinjiang. This system not only integrates information sharing and applications, but also provides emergency reporting and handling, as well as command and dispatching. So the transportation one map is already a complete platform. The next we'll continue to talk about how to optimize transportation construction with 3D GIS technology. Uh, Firstly, we want to know why we need this 3D technology. Uh, at the present, many 3D entities have been formed in the main roads, bridges, tunnels, and culverts, especially the main connecting lines and roads around the city, are mostly complex overpasses. And we lack effective 3D display means and traditional maintenance is mostly based on the management and application of 2D vector data, lacking the ability to restore the terrain around the road to 3D scene and cooperate with emergency rescue to develop an overall solution. So we need 3D technology to display the 3D entities and make an overall solution with 3D analysis. So let's look at how 3D GIS assists for transportation construction. Firstly, 3D GIS provides better visualization of reality scene. We can view the sky, the objects on the ground, even objects underground at the same time. It also can solve practical problems such as the height design of overpass and displaying interior space such as the tunnel model. Meanwhile, 3D technology makes the intelligent thing as possible. You may wonder what kinds of 3D models are supported. Here lists some main 3D models like oblique photography, beam, point cloud, the 3D terrain fan model, and all these are supported to integrate with SuperMap. The way to match multi-source 3D data is converting 3D model to a format that GIS tool accessible, and the model integrity, attributes, and the consistency uh, between graph and the model should be ensured after data viewing. Um, and the last, each model is added to the scene as a layer. Here, let's see some cases of the 3D model viewing. The first one is the integration of 2D vector line with oblique photogrammetry by 3D symbolization. And this is the integration of 3D model of professional modeling software and SuperMap. This video shows the integration of beam with oblique photogrammetry. 3D terrain, image, and other graphic data. The status of the viaduct under construction and the work site, as well as the terrain around it, is vividly displayed. 3D GIS also provides many analysis functions. There are four aspects. The first operation is 3D spatial expression, which not only display the realistic object, but also the shadow body, visible body, and the skyline. And the second aspect is 3D functional operation, which including spatial operation, spatial relation judging, spatial analysis, also 3D measurement. 3D model can also be converted to 2D data and can realize 3D print as well as volume computing. Customized development is also supported with WebGL. So here we look at some results of 3D analysis, the 3D slope and aspect analysis, profile analysis, 3D isomer analysis, and the 3D buffer analysis. The minimal vertical clearance often needs to be sure in the design state. This 3D model can well display and measure this value. The tunnel body model is built by convex hull, and the spatial operation between convex hull and mounting body is realized to dig the tunnel. We can construct road by setting out to get a road model. Or we can just simply symbolize the 2D line data to integrate with the oblique photogrammetry model. 3D analysis also can realize some 3D spatial relationship queries and judging the relationship between two spatial entities. The example shows the intersection results of subway and building. The buildings that intersect the subway are highlight displaying. In the practical application, integrated 2D and 3D technology, the system can display 2D and 3D integration scene. View the overall status with 2D view and at the same time display core construction scenes with 3D model. Also can monitoring the construction status. And checking the risk sources. Also highlight the risk sources. Meanwhile, we can create the details of each risk source. Meanwhile, in the mobile terminal, it can realize 2D and 3D integrated visualization and 2D and 3D integrated navigation, as well as indoor and outdoor integrated navigation. And last, let's look at the application of big data in traffic construction. First of all, we need to briefly know what constitutes the big data GIS technology system. Um, Cross-platform and ecologies is the basic technology of big data GIS. The core technology of SuperMap big data is big data storage management, distributed analysis, stream data, and big data visualization. We already know the diversity of traffic data sources, but how to store the growing amount of basic graphic data and semantic data, and how to highly efficient display them. SuperMap provides SDE, web engine, and multiple distributed SDX to solve the storage issues of big data. Let's take a look at the result of amount of 450 million line data based on HBase storage. It is displayed smoothly in the system. Big data analysis operators based on SuperMap and Spark are growing. SuperMap provides different analysis operators for 4 different types of data. Based on these analysis operators, the results of big data analysis can be displayed in a deeper level. Like OD analysis, the principle of OD analysis is to mine and analyze the starting and ending points of traffic and the connecting degree between stations from big data. The video shows the comparison of morning and the evening peak flow between 2 subway stations of Beijing. This example shows the display of a large number of land parcels with 10 distributed clusters, then do buffer analysis and overlay analysis to calculate the occupied land parcels, which only take less than 45 seconds. Integrated with IoT technology, big data GIS can realize real-time monitoring through streaming data service and distributed service, as well as big data analysis. In this example, real-time query of road conditions is realized based on distributed storage and big data analysis by accessing real-time traffic flow data. And this video shows the statistics of taxis get-off points in the evening rush hour based on big data hotspots analysis. Based on the taxi data, analyze the contact degree of each district and county, where are population input areas and where are population outflow areas. This video shows the number of global airplanes in a certain period of time based on big data aggregation analysis. So that's all for my presentation. Thank you for your listening. And if you have any question, please feel free to contact with me by this email. Thank you.